What is up, YouTube, and welcome to another video. In this video, I'm going to talk about the basics of running Kubernetes in the cloud. Today's cloud is going to be Microsoft Azure. If Microsoft Azure is not your cloud, feel free to follow along and learn about Microsoft Azure. In this series, we'll be covering multiple cloud providers, so stay tuned for other cloud providers as well. That means no cloud automations, no Terraforms, no complexities. We're going to go back to basics. And once you get the basics right, you can use any automation or provisioning tool you like because you will understand the fundamentals of running Kubernetes in the cloud. So fundamentals is key. So let's get started. So you'll want to go over to Google, type Azure free account, and then look for the Microsoft link that says create your Azure free account today. Now with this account, what we can do, we can just sign up with like a throwaway account, email address, where we'll get 12 months and $200 free credit. That should be sufficient to do everything you need to do for this video, and then you can delete everything once you're done. So I click on start free. Now to prevent fraud, almost every cloud provider is going to ask you to prove your identity, and they're going to ask you for credit card information. The reason they do this is to prevent fraud, and they should not charge your card at all. And make sure you follow this guide. But what we're going to do is we're going to make sure we delete everything once we're done. So we will be using minimal credit to provision everything, and we'll destroy the resources once we're done. So there should be absolutely no charges. Once you have your account, we're ready to roll, and we can click on go to the portal, and we can go and explore all the resources and things we can actually do. So in this video, what we're going to do is we're going to create a free Microsoft Azure account. Every account in Microsoft is managed by an Azure Active Directory. Active Directory is used by organizations to manage user accounts. It is also used to manage service accounts. In Microsoft Azure, this is called a service principal. There are also managed identities that Microsoft can manage if you don't want to create a service principal. We're going to stick to the basics. What we're going to do when we create a free account, we also get access to a free subscription. A subscription is a way to group resources together under the same billing account. So it's basically used for billing. Inside the subscription, we're going to create a resource group. Resource groups are used in Azure as a logical grouping mechanism to group resources together. So everything you deploy, you can deploy it as part of a resource group. So what we're going to do in this video is we're going to deploy a Azure Kubernetes cluster inside of this resource group. And what we're going to do is we're going to create a service account to manage this resource group. This allows Kubernetes to create load balancers and disks and do things in the cloud. Most cloud providers require a service account to allow Kubernetes to manage cloud resources on your behalf. So if you're new to this channel, everything I do on this channel is in GitHub. So you want to go over to my Docker development YouTube series, look for the Kubernetes folder, and for this cloud series, we'll be making a Azure folder, and inside there I have a getting started template. This is everything we're going to be doing in this video. It's all on GitHub. Check the link down below so you can follow along. Right, so we're taking a look at getting started with AKS and the Azure CLI. Now, every cloud provider that you work with usually interfaces with a CLI. So you need some kind of command line interface or SDK to talk to the cloud provider. So the easiest way to do this is to use Docker. So if you go over to Docker Hub, you can search for the Azure CLI, and you can find a lot of information about what it is, how to use it, and a full tag listing of versions that you can use. So in this video, I've put the command out here. We're going to be using 2.6.0. So how we use it is we say docker run, we remove the container when we're done, we mount in a volume that's going to have our source code so we can interact with the source code inside of the container, and we set a working directory. We also tell the container we want to use bash, and then we specify the name of the container image and the version, and that will give us access to a terminal where we are now in Docker and we can use the CLI. So the first thing we can do is type AZ. That'll bring up the Azure CLI and all the commands that we can run. So if we take a look at the commands, we can see everything in Azure we can interface with. So we can interface with accounts, private container registries, we have like app services, we have deployments, disks, virtual machines, pretty much everything in the cloud. So what you can also do is say az aks -help. The nice thing about CLIs is that they are generally self-documented, meaning that every command has a document and a tooltip saying what that command is used for. So in this case, we can see AZAKS, we can have sub-commands such as node pools, we can have commands such as how to create a cluster, how to delete a cluster, how to get the credentials, how to get the different versions of Kubernetes available, and a bunch of other things. So feel free to use the help command if you're stuck and you need more information. So since we are in the container, we can now switch over to the Kubernetes Azure folder. So I'm going to say cd Kubernetes Azure. And if we do ls, we can see the getting started guide. So we're in the container and ready to go. So the first thing we'll want to do is say az login. This will allow us to log into Azure using our free account. So you're going to want to head over to this URL. So take this URL, paste it in your browser window, and just follow the prompts. It'll ask you for the code. So you're going to need to take the code and paste the code into the browser window and follow the remaining prompts to log into your account. Once you've logged in, you'll see a window similar to this saying that you've now logged in, so you can close the browser. And now you can see we've logged into our account, and it's a free trial account. So then the next thing we'll want to do is have a look at what accounts we have available, or subscriptions. For that you say az account list -o table to get a tabular output. And we can see we have a subscription. This is our subscription ID, and it's a free trial Azure account. Now, if you have access to multiple subscriptions, you might want to run the set command to make sure you set the default subscription to the one we're going to be working with. To do that, you say az account set, and you pass in the subscription ID. So all the subsequent commands that we run will run against the subscription. Now, to make things simple, I'm going to create a couple of environment variables that we can reuse. So the first thing I'm going to create is an environment variable called resource group. So this will allow us now, we're going to create a resource group that's going to hold all our resources. First thing we'll want to do is say az group create. So we're going to create a resource group called aks getting started, and we're going to create it in a specific location. So Azure has multiple data centers, so you want to look up the location name that's closest to you or your customer for where you want to deploy this Kubernetes cluster. I'm going to deploy mine in Australia East. Now, as I mentioned earlier, all accounts in Microsoft is managed by an Active Directory tenant. So you'll have a default Active Directory tenant that manages your entire subscription. So in order to deploy Kubernetes, there needs to be some service account that can manage cloud resources. So what we're going to do is we're going to create that service account called a service principal, and then we're going to provide a permission scope as contributor rights across a resource group that we want Kubernetes to manage. So in order to do that, we're going to run a command called azadsp create for RBAC. That's the command. So it's basically Azure Active Directory Service Principal create, and we're going to skip role assignments because we're just going to do one basic command. We pass a name for the service principal, and we want the output as JSON. So what I'm going to do is I'm going to pipe this command into an environment variable. So when we run this, the output is going to be JSON, and it's going to be run inside of this environment variable. So the output will be inside of this guy here. So to show you, I can just say echo, just print that out. So we can see we have a bunch of stuff. We have this, the service principal has a password, it has a name, a URL, and a bunch of things. So you want to keep this password secure, because this password is just like a user account pretty much, but it's basically a service account that has contributor rights over this resource group that we're going to do now. You'll also want to keep this username and password for later use, and you want to record it somewhere and keep it safe. So we can furthermore now use that JSON output to grab the ID of the service principal and the key. Those are the two important information. So you can see I'm going to create another environment here, variable called service principal, and this is going to hold the app ID. So I just use a utility called JQ, and I read the JSON that's inside this service principal JSON environment variable I showed earlier. So we run that, and then I'm also going to do the same thing for the secret. So I'm going to read the password as well. So now we have the service principal name and we have the service principal secret. Now that we have a service principal ID and a key, we want to use the service principal to manage our Kubernetes cluster. So what we're going to do next is assign a role for that service principal to give it contributor rights to that resource group. So it basically can manage the resource group itself. This will allow Kubernetes to do things like issue load balancers, create disks, create vaults, and whatever Kubernetes wants to do inside of the boundaries of that resource group. So what we're going to do now is say AZ role assignment create, and the assignee is going to be our service principal, and the scope is going to be the on the subscription, inside the subscription to the resource group and that specific resource group that we've just created. So the service principal will not have access to anything outside of that resource group. So it's very important to restrict the boundaries so you know exactly what the service principal is used for. It's key, so you know when it's expired, and you know when you rotate that key that you know it's only Kubernetes that can be affected by this. So, and we're going to give it contributor rights because it has to be able to create, update, and delete stuff inside of Kubernetes. Now, I forgot to create a subscription environment variable. So what I'm just going to do is I'm going to say AZ account list again as a table, and I just want to create another environment variable that holds my subscription ID. It just makes things so much easier to use environment variables. So we're going to say AZ role assignment create, service principal, apply the scope, and we want a contributor role. And this is going to go off and do all that magic. So if I say AZ AKS create and I pass the help flag, you can see that I'm presented with all the options. So the required options, and this is the cool thing, if you just want to get started, you just have to specify like a name and a resource group. There are only 2 required flags here to get going. This is something that a lot of other cloud providers don't do. Makes it simple just to get started if you don't care about all the nitty-gritty. But if you want to get into the detail, we'll go through some of them at a very high level. So you've got the like Azure Active Directory values you can specify. This is if you have an Azure AD already in your account and you want to bring your own authentication. So your users in your company can use their Active Directory account to log into Kubernetes and use kubectl. So that's a very handy feature. We also have the admin username. This is for SSH and things like that. You have the service principal secret that you apply. You can also attach a container registry from Azure as well. And then what we can do, some other features here like enable add-ons. So Kubernetes also in Azure allows you to bring some monitoring tools or log analytics or whatever like extra add-ons Microsoft can provide. They have that. They also have a cluster autoscaler. You can enable managed identity. So managed identity is kind of like a service principal, but it is managed by Azure. So Azure manages the service principal account that that manages your Kubernetes cluster. Then we can also get SSH keys generated automatically, or we can bring our own. We can specify the Kubernetes version. Then Microsoft also has a ton of details around the load balancing and how you want the Microsoft or Kubernetes to manage the load balancer for you. Microsoft has a bunch of different flavors of load balancers available. So if you really need a specific load balancer and you need to control some of the settings, this allows you to do so. Then we also have location. So we can deploy our Kubernetes cluster to different locations, data centers basically. You can specify custom network plugins. So we're just going to use KubeNet in this example, but network plugins are basically ways of bridging the machines or the nodes so they can run on like different networks. So the default is KubeNet, but if you want your pods to run on the Azure network, you can use Azure as a network plugin. Then we also have, what else do we have here? We have a lot of settings about nodes. So this controls sort of how many nodes you want, what sizes they need to be, what their disk sizes is, what operating system they should be, whether it's Windows or Linux. And you can also define node pools. So you can have groups of different nodes. So you can have like GPU machines, or you can have machines that are memory optimized, or you can have like large disk for storage machines. So it's entirely up to you. You have that flexibility. The other thing you can also do is you can also drop your Kubernetes cluster into a private VNet. So this is really handy if you already have quite a large infrastructure in Azure set up already. You can just drop your Kubernetes cluster in the same VNet so it can talk to things on that network. And then you also have like Windows admin usernames and passwords. So you can have a Windows node as well as Linux node running in this Kubernetes cluster. And then the other thing I like about the CLI is it also has a ton of examples with different use cases you can try out. So for example, if you're interested in spinning up Windows and Linux node pools, you can try this use case. If you need user-defined routing for outbound traffic, you can do that. If you want to try out managed identity, you can do that. And there's like standard load balancer as well as just the normal load balancer, and then it goes up to the very basic thing about I just want a cluster. I don't care about all the things underneath. Now before we spin up our cluster, we're going to want to generate an SSH key. So I'm using SSH key gen. I'm passing a very super strong secret, and I'm just going to generate an SSH key. You can also just bring your own, and then because it's generated in SSH folder, I'm just going to copy it to the root here. So if we say ls, we can see our SSH key, private key and public key has been generated. You can also tell the CLI to generate one for you. I just want to show you this way in case you want to bring your own. The other thing that's important to know is that you want to know exactly what size machines you want to deploy in your cluster. So Microsoft has different sizes for Linux virtual machines in Azure. So they have like general purpose, which is balanced CPU to memory ratio. Then you have compute optimized, which is more like high CPU to memory. And then you have memory optimized, which is more about memory focused machines. You have storage focused machines, you have GPU focused, and high performance. So when you click into one of these, you can then go in and say, okay, let's take a look at memory optimized. We can take a look at like E series, for example, which is really high memory. And what you want to do is you want to grab the SKU number for that machine that you want to deploy. That's very important before you even start creating a cluster. Now in my GitHub repo, in my getting started file, I have recorded all the commands so you can follow along. And I've created a very sensible AKS create command here. That has all the basic things you're going to need to create a cluster. So I say az AKS create. I pass in the name of my cluster. I give it a resource group. So this will put that cluster in that resource group that the service principal can manage. Then we say we want the cluster to go into Australia East. We want a specific version of Kubernetes. We want to use a standard load balancer. If you leave it out, it will just give you a basic load balancer. I want to specify the node pool name. This allows you to add multiple node pools later on, and you can give each one of them a name. And then what we do is we say node count 1. I just want one node, and I'm going to pick an E series machine for this example. So it's memory optimized. You might be running memory caches, or you might be running data storage or something. So you have to pick the right SKU for the job. And then what I'm going to do is I say I want an OS disk size of 250. This is also very important because what I found is that the sensible default in Azure for virtual machines are not big enough if you're going to want to run a Kubernetes cluster. Remember, Kubernetes, depending on how you run your pods, will need to store Docker images on the disk. And by default, some of these disks are like 20, 30, 40 gigabytes, which is not really good enough. So you want to provision something at least over 100 gigabytes. Otherwise, you're going to be running out of disk very quickly. So I'm going to say I want 250 gigs of disk. And then here I specify my SSH key. I also say I want to run KubeNet, which is the basic network plugin. And here's the service principal name and secret. So the service principal that's going to be managing our Kubernetes cluster is specified here. So that is all you have to do. You can just take this command as it is, and we can go ahead and paste it in the terminal. You'll see it'll start saying this running status. That means now Azure has gone off and created our cluster, and it generally takes about 5 minutes or so for the cluster to be ready to go. So in the meantime, if we go over to portal.azure.com, there's a few things we can do. We can either go and search for our Kubernetes service, so we can type Kubernetes, and we can look at all Kubernetes services in our account, or we can also look at all the resource groups. So if we type resource group, we can see this is the managed resource group that the service principal is managing. So our Kubernetes infrastructure is inside of this resource group. You can see here it's starting to provision the load balancer, the public IP, and you'll see all the virtual machines come in here. On the other one, this is our resource group that we've defined. We can see our AKS has been created. If we click into that, we can see it's still in creating status, and you can have feel free to play around here. You have node pools, you have upgrade, you have scaling, so you can scale the machines up and down. There's Azure Dev Spaces, there's Deployment Center, there's a bunch of policies and metrics, insights, and diagnostic settings and things you can have a look at here. But I'll leave that up to you to play with. So once our Kubernetes cluster is finished, it's been created, we can then say AZ AKS list, and we can see what Kubernetes clusters exist in our resource group and entire subscription. This is the one, it's been created. We can see provisioning status succeeded. So now we have a Kubernetes cluster, we can go ahead and access it. So there are multiple ways of logging into your Kubernetes cluster on Azure. There's two ways that I'm going to be covering. The first way is to just get a user credential, and the second way is to get an admin credential. The other thing is, if you have linked your company's Azure Active Directory to the Kubernetes cluster, you'll be able to define RBAC roles within Kubernetes. And whenever someone types a kubectl command, they'll be presented with a login screen where they need to actually sign into your Active Directory first. So what you do is you say AZAKS get credential and the name of the cluster and the name of the resource group. This will give you a user config. Now by default, this user will have no permissions set up. So we're going to need an admin to define RBAC roles in Kubernetes, because by default RBAC is always enabled. So in this demo, I'm going to say --admin. So the first person would generally require an admin credential so they can go in and manage the RBAC roles, and they can set up access for other users to use the Kubernetes cluster. So you can see it has gone and created a AKS getting started admin context in our kubectl config file, and it's put it into a kubeconfig. So if you want to go ahead and grab that, because remember we're inside of the CLI container here, if you want to go ahead and grab that out, you want to do CP and just copy it out there and put it in the folder, so you can then go ahead and store that somewhere securely, so you have your config to access your cluster. Now because I'm in a container, I'm going to need to go and grab kubectl. So that's very simple. I'm just going to curl get the latest version of kubectl, and then I'm going to chmod, give it execution permissions, and move it to user bin. So now I can say kubectl get nodes, and we can see we have our AKS node ready to go. So we now have an admin account. We can go ahead and set up RBAC permissions if we like, but in this video I'm just going to show you how to do a basic deployment, just so that we can show you how to interact with the cluster. If you're interested, take a look at the links down below. If you want to know more about how to configure kubectl, how to run Kubernetes on Docker for Windows and Mac locally, how to do deployments, config maps, secrets, and ingresses, I have a Kubernetes getting started guide. In this video we're not going to be doing CI/CD, but I'm going to have a separate video focused purely on using CI/CD tools to deploy applications to AKS. In my Docker development YouTube series GitHub repo, I have a Kubernetes folder, and I do deployments, config maps, secrets, pods, and pretty much all the YAML stuff here as part of my Kubernetes development guide. So what we're going to do now is I'm just going to change my directory into the Kubernetes folder. Then we're going to say kubectl create namespace, and we're just going to create a namespace called example app. So this is going to hold all of our Kubernetes resources together. Then I'm going to say kubectl apply, and I want to apply inside the example app namespace. I want to apply a file, and I'm going to say deployment.yaml. This is going to go ahead and apply a deployment to Kubernetes with an application running a Hello World application. It's also going to require a few things. So we're also going to require a config map. So I'm going to apply a config map, and it's also going to require a secret. So I'm going to show you how to do that. So we just say secret, and to expose the application, we're going to want to use a service. So I'm going to say service and service.yaml. But before we take a look at that, let's take a look at the service itself. So you can see I have a service here, type cluster IP. We're going to change this to load balancer. Because we're running in the cloud now, I want to show you guys what it looks like when Kubernetes issues a load balancer service and exposes our app publicly. So then I say kubectl apply and I apply the service.yaml. So if you're interested, you can have a look and play with these files. So under the deployment folder is a deployment YAML. We basically just say we want 2 replicas of an application. I'm running just a Python hello world application, and you can play around with things like liveliness probes, how much resources we want the application to use. We mount a secret as well as a config map. This just shows you how to do secrets and configs in Kubernetes. Then I also have example of a config map folder, so you can see what a config map looks like in Kubernetes, and also a secret, so you can see what a secret would look like in Kubernetes as well. And this is part of my Kubernetes development guide. So if we're given this some time now, we can say kubectl get pods, and we see this these pods have been created. We can also see, if we say get deploy, we can see our deployment is there with 2 out of 2 pods running. The other thing I also want to show you is we say get service, and we can see now we have an example service created as a load balancer. So Kubernetes went to Azure, created a load balancer with an external facing IP. So I can go ahead and take this IP and I can go to the browser and I can pull it up. See, so now we have Hello World running inside of a Kubernetes cluster on Azure, exposed through a load balancer. So remember, once you have done all of this stuff on your free account, that you want to go ahead and clean up. So I have a cleanup command here. The first thing we want to do is go ahead and delete the entire resource group. So this is really cool about Azure, and that's the fact that you can group things in a resource group. It makes it really easy to clean up afterwards. So we just say AZ group delete. I say yes. That's going to go ahead and delete the group, as well as everything that Microsoft has provisioned inside of that resource group, and the management resource group as well. And then the last command we want to do is add delete, and we want to delete the service principal accounts as well, because we don't want to have these service principal accounts lying around, because they do have access to our subscription. So that's it for the first part of the series, Kubernetes in the cloud with Microsoft Azure. Stay tuned for more cloud providers, and let me know down in the comments what sort of videos you'd like me to make in the future. And until next time, peace.